Ladies and gentlemen, it's the moment you've all been waiting for. You've been talking about this for some time. Are we ever really going to do proofs? Heck yeah. And I made this title page as exciting as you are excited about this. It just says congruent triangle proofs on a blank white page. So much excitement. How about we throw down an exclamation point? You know what? How about 3 of them? Yay! Triangles congruent. Okay. Our first proof here, and this one we're going to keep it a little simple at first. We got a lot of given information here. So what we do here with these proofs is, well, if I got my given information, I like to label down on my diagrams when possible. Okay? So I've got AB is congruent to XY. So I'm going to put a tick mark on AB. Oops, there we go. And then I'll put a tick mark on XY, noting that those two are congruent. Okay? I've also got CB and ZY congruent, so I'm going to mark those two with 2 tick marks. I want to differentiate between them because we don't know if AB is congruent to CB, so we need to use 2 tick marks instead of 1 to differentiate between those. Okay? Next, I got my angles. Angle B, I do an arc there, and angle Y, I do an arc there. So, our proof here is that triangle ABC is congruent to XYZ. Now, looking at these diagrams, we do have 3 pieces of information. What are those? We've got a side, an angle, and a side. We've got a side, an angle here, and a side. So this proof is only 2 steps. We set it up as our statement, our reason. Our first step is our given. I'm just going to go ahead and draw a line down and then around to our given because that's a lot to write here, especially with this marker that I'm using on an iPad here. I'm using my finger to write, so it's a little tough to write that small. Alrighty. So I have enough information to prove these triangles congruent, so I'm going to write down my proof. And my reason is side, angle, side. Awesome. Remember we got those 4 that we were learning about. Side, 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 angle, side, angle, and angle, angle, side. Woo! Alrighty, our next one. We'll do a little bit longer this time. So I've got angle A is congruent to angle C. I'm going to go ahead and label that A and C. Now I've got angle CBD is congruent to angle AB. Oop, ABD is what I meant to write there. Oh my goodness, Mr. Allen. It should be ABD. Oh my goodness. Can't believe myself. I'll get by. It's okay. So ABD. All right, so I notate that one with 2 tick marks. And notice how I use 3 letters to name those angles, because if I just said angle B, we wouldn't know what we're talking about. I don't know which angle you're talking about, so I do need to use 3 letters, with B being my vertex. Okay, the center one is my vertex, where it gets to a point. All right, so I want to prove that triangle ABD and CBD are congruent. So let's do that. I'm just going to write S and R, statement and reason. I'll abbreviate those. And I've got my given information. I'm going to draw a little arrow up into there. And then now we're at step 2. Do I have enough information to prove these triangles congruent? Well, I've got an angle and an angle. I've got another angle and an angle. So it looks like I'm going to need a side. Now I can either go with, if I have the information, I can either go with this side and this side, this side and this side, or it looks like BD is shared between these 2 triangles. Now, I don't have any information to get AB congruent to BC. I also don't have any information to get AD congruent to DC. But do I have the information to get BD congruent to itself? Heck yeah. You're fine. Miss Zaleski is leaving the building.
Bye-bye.
All righty.
Be so quiet.
So, why is BD congruent to itself? It is called reflexive property. Remember that one? DB is congruent to DB. That is reflexive property. Now, that is a side and a side, right, of our triangle. So we have angle, angle, side is going to prove these triangles congruent. Awesome! Triangle ABD is congruent to triangle CBD, and that would be angle, angle, side. Awesome. That is fantastic information. Alrighty, let's do uno más and call it a day. All right, last one of the day, and this one is the most difficult. It will be a little bit longer, like 4 or 5 steps. All right, so it says in our given that E is the midpoint of AC and BD. Well, what does it mean to be a midpoint? A midpoint will split a segment into 2 congruent segments, which means that AC has been split in half into 2 congruent segments, so AE is congruent to EC, and then since it's also the midpoint of BD, it splits these two. And I got to notate them with different tick marks. I don't want that to look like 3. There we go. Because we don't know if all 4 of those are congruent. We just know that BD has been split in half, so DE and BE are congruent. And I know that AC has been split in half, so AE and EC are congruent. Okay, and we went over the definition of midpoint in one of the other videos. Now, I've got 2 sides, so I either need to get DC congruent to AB, which I don't have any information to do, or I can get these 2 angles congruent and do a side angle side type of deal, right? So I've got a side and a side. I've got another side and a side. So if I can get the angles right here, I'm going to get a side angle side. So I don't have the information to get this to do side, side, side. Well, why is angle AEB congruent to angle CED? Or you can even label it as angle 1 and angle 2. You can throw numbers in there if you'd like, okay? So that can be nice to use numbers. If you label it on your diagram with numbers, you can use that in your proof. Why are those 2 angles congruent? If you remember vertical angles congruent, then you are the winner. All right, so I've got my given information. Whoop. And now we can say that AE is congruent to EC by the definition of midpoint. Or if you just wrote midpoint, I'm okay with that as well. Now, aren't BE and ED congruent for the same reason? Absolutely. So we can actually keep that all in one step, and that saves us a little time in writing definition of midpoint again. Just put it all into one step. Since BE and ED are congruent by definition of midpoint, AE and EC are congruent by definition of midpoint, they can be combined into one. And another reason why they can be combined into one is that these 2 being congruent is not affected by these 2 being congruent and vice versa. It's not like you get this one from this being true or vice versa, so they can be in the same step because one doesn't depend on the other. Okay? And lastly, angle 1 is congruent to angle 2, vertical angles congruent. So, do I have enough information to prove the triangle is congruent? Heck yeah, by side angle side, as we said. So I'm going to have triangle ABE is congruent to triangle CDE. Woo-woo! Lovely. That was our first day of proofs. Now I have a question for you. Do you think any of these other pieces of information would be congruent? Like, could I get AB congruent to CD? Would it make sense that they are congruent if these triangles are congruent? Absolutely, it would make sense that those 2 are congruent, and that's what the next video will be about. Corresponding parts of the congruent triangles are indeed congruent. Ooh, that was awesome.